Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this session, we are going to see about the analysis of coal by proximate method. So there are two different types of analysis. One is the proximate analysis and another is the ultimate analysis. In this video, we are going to see about the proximate analysis. So introducing this, so coal we already seen in the introduction part. It is an organic sedimentary rock that forms from the accumulation and preservation of the plant materials, usually in a swamp environment. Coal is a combustible rock and is one of the three most important fossil fuel. So coal is a wide range of uses, and the most important use is the generation of electricity. Okay, so you have different types of coals: bituminous coal, anthracite coal, and lignite coals. So the coals are classified is into different types. That is the wood. Okay, when you actually what is coal is nothing but it is the plant and the animal matter when that is present in the earth's crust under the pressure and temperature for millions of years to get the coal. Okay, so first the uh, wood, for example, it will be converted into peat. That peat it will be converted into lignite. It's a type of coal, and after that it is converted into bituminous coal. Then further under the temperature and pressure, it is converted into anthracite. Okay, so the anthracite is a very good quality coal. The process of conversion or the alternation of a vegetable matter to anthracite coal is called the coalification or metamorphism of coal. So, this process of conversion of wood into anthracite is known as the coalification process, otherwise, it's called as the metamorphism. So coal is classified on the basis of its rank. Okay, the rank of the coal indicates its degree of maturity. Here you can see that the wood is the immature one and the anthracite is the most mature type. So classification of fuel, we are going to see about the fuel, the nature of that fuel, calorific value in kilocalories per kg, then composition and the uses. So first is peat. This is highly fibrous, light brown in color. The calorific value is from 4000 to 5400. Composition is you have carbon 57, hydrogen 6, oxygen 35. It is used as a domestic fuel and it's also used for the power generation. And the next one is the lignite. So it is a fibrous, brown colored fuel and its calorific value ranges from 6500 to 7100. Composition: carbon is 67, hydrogen 5, and the oxygen 26. Manufacturers of producer gas and steam is the uses of this lignite. And next is the sub-bituminous coal. So this bituminous coal is further divided into sub-bituminous coal and bituminous coal. Okay, so it's a black colored, homogeneous, smooth mass and its calorific value ranges from 7000 to 7500. Composition: it has carbon 77 percentage, hydrogen 5 and oxygen 16. So manufacture of gaseous fuel it's used. And next is the bituminous coal. So it is a black, brittle, burns with yellow smoky flame. Its calorific value ranges from 8000 to 8500. The carbon percentage, see you can see has a start from the beginning. Now the bituminous coal, the carbon content percentage is high. It's becoming higher in each rank. Okay, so carbon is 83 percentage, hydrogen 5 and oxygen 10. It's used for the power generation, coke making and for the domestic fuel. And next is the anthracite. This is the highest ranking fuel and it's hard and most matured coal and burns without smoke. It has the calorific value ranging from 8500 to 8700, carbon 93, hydrogen 3, and oxygen also 3. So the boiling, heating purposes, metallurgical furnace it's used in. So the progressive transformation of the wood to anthracite results in, as we see from the properties, decrease in the moisture content. As it becomes the anthracite, the moisture content is very low over there, decrease in volatile content. That is a liberation of harmful gases. Okay, that is also decreased. Decrease in hydrogen, oxygen, nitrogen, and sulfur content. Okay, only the carbon content will increase and the hardness and also the calorific value will be increased. So as the rank is higher, the quality of the coal is also higher. So we are analyzing the coal. In order to assess the quality of coal, the following types of analysis are made. Proximate analysis: moisture content, volatile content, ash content, and fixed carbon in the coal are found by the proximate analysis process. So, first is the moisture content. For determining the moisture content of the coal, you are taking 1 gram of the powdered air dried coal sample in a crucible and it is heated to about 100 to 105 degrees centigrade in an electric hot air oven for about 1 hour. The loss in weight of the sample is found out and the percentage of the moisture is calculated as loss in weight of the coal upon weight of air dried coal into 100. Next is the volatile matter. After the analysis of the moisture content, the crucible with the residual coal sample is covered with the lid and is heated at 950 plus or minus 20 degrees centigrade for 7 minutes in a muffled furnace. The loss in weight of the sample is found out and the percentage of the volatile matter is calculated as the loss in weight of the coal upon weight of the air dried coal into 100. And the next is the ash content. So volatile matter analysis is followed by heating the crucible with the residual coal sample without lid. So here you are going to remove the lid and at 700 plus or minus 50 degrees centigrade for half an hour in a muffled furnace. The loss in weight of the sample is found out and the percentage of the ash content is calculated as the weight of ash formed by the weight of air dried coal into 100. So this will give you the percentage of ash content in coal. Next is the fixed carbon. So it is determined by subtracting the sum or total of moisture content, volatile matter and the ash content from 100. So we have calculated all these things in the previous steps. So we are going to subtract all these things from 100. So percentage of the fixed carbon in coal will be equal to 100 minus percentage of moisture content plus volatile matter and ash content together. So we'll see what's the need for the proximate analysis. High content of moisture is undesirable due to the following reason. Okay, so if the moisture is very high in the coal, it reduces the calorific value of coal. Moisture in coal consumes more heat in the form of latent heat. So there will be loss in the heat, okay, of evaporation and hence more heat is supplied to the coal. It increases the transport cost and high content of volatile matter is undesirable because it reduces the calorific value of the fuel. Large proportion of the fuel and heating will distill over as vapor which escapes unburnt. Okay, so there is loss in the fuel and high percentage volatile matter gives high smoke. Next is the high content of ash is undesirable due to the following reasons. If there's more ash in the coal, it reduces the calorific value of the coal. Ash causes hindrance to heat flow as well as produces clinkers which blocks the air supply through the fuel. So transporting, handling and storage costs are high and the additional cost is ash disposal. Next is a high percentage of fixed carbon only is desirable because it gives the high calorific value. The percentage of the fixed carbon helps in designing the furnace and the shapes of the firebox. Thank you.